If you're studying for the GED Mathematical Reasoning Test, this video is for you. Relearn what you need to know, starting with the most fundamental information: numbers. This is part one of a multi-part math playlist, so be sure to check out the links in the description. Let's get started. In this video, we're going to talk about numbers. And you have this number here, 4,082. We have place value. We will talk about place value here in this video, and then when we get to decimals, we'll talk about the other place values, the tenths, the hundredths, the thousandths. What we're also going to talk about here too are ways to classify numbers, because that is often a topic or a question that students will ask. What's the difference between an integer and a whole number? What makes something rational versus irrational? And then we'll finish up with the example that you see here. So numbers, yes, we know what numbers are, but I want to talk about them a little bit more in detail. First of all, we have the place value for the numbers: the ones, the tens, the hundreds, and the thousands. Let's consider another number, 5,237. Now, I'm just making up another number here because I want to have a non-zero digit in each place value to explain the concept here. Now, this is the thousands, this is the hundreds, this is the tens, this is the ones. When we see that 5 in the thousand spot, just like we see this 4 in the thousand spot, this means you have 5,000. A way we can commonly write that is 5,000 because we have a 5 in the thousand spot. This 2 lies in the hundred spot. That means we have 2 hundredths, or 200. This 3 is in the 10 spot. That means we have 30, or 3 tens. And then we have a 7 in the 1 spot, so that's a 7. And if we come and add this up, we do get 5,237. And one more thing I want to point out here is this: the way we say this number. Sometimes I'm even guilty of saying this. I'll say 5,237. Technically, we don't want to use the word "and" anywhere in this number. We read it as 5,237. The word "and" actually pops up when we have a decimal and we have more digits over here. But more on that when we get to the decimal section. Now, we have this number. How can we classify this number? And we have this chart from Smart Addition to help us with this. So we have natural numbers, whole numbers, integers, real numbers, rational numbers, and irrational numbers. There are other sets of numbers, but we will not cover those in this lesson. Natural numbers, your plain old counting numbers, but we don't include zero, we don't include negative numbers. The lowest natural number is 1. You may wonder what the biggest natural number is, and there is no biggest natural number because we can count forever and ever and ever. And the only difference between a natural number and a whole number: the whole number includes 0, but then it's all of the other natural numbers as well. So notice it's the natural numbers plus 0. Natural numbers, 1, 2, 3, 4, 5. Whole numbers, same thing except we have a 0. Now, if we start tying in the negative numbers, that's where integers come into the picture. No decimals, no fractions, but we have all of the whole numbers, 0, 1, 2, 3, etc., but we can also go in the negative direction. So that's what integers are. Real numbers, every single number that we know to an extent is a real number. There is an additional number group called the imaginary numbers, but we will not discuss those in this lesson. And then we have rational numbers. Rational numbers are numbers that you can write as a fraction. Well, okay, if we take 2 and we put it over 1, that is a fraction. And I want to go ahead and clear the air on that. The natural numbers, the whole numbers, and the integers, these three groups of numbers that we've talked about up here, we can write all of those as a fraction. All of the natural numbers, all of the whole numbers, all of the integers, they are rational numbers. But then we have, fractions such as 2/3. That is not a natural number, a whole number, or an integer. This is a fraction, and that is a rational number. Then we have decimals, 0.5. You can write 0.5 as a fraction, and we will see this later in the other lessons, but 0.5 is a half. That is a fraction. That is a rational number. Now, there are some decimals that you cannot write as fractions. Those decimals that we cannot write as fractions are called irrational numbers. One of the first numbers that come to mind is the number pi. Now, whenever you see pi, you probably think 3.14, which is fine. But technically, that's not just pi. Pi is a decimal that goes on forever, and there's no pattern in that decimal. Now, that may be a little bit confusing right now, but when we talk about decimals, and especially when we get to geometry, we will see this. But there are other numbers that are not rational. Now, let me write another number up here, the square root of 25. Now, the square root of 25 is 5 because 5 times 5 gives you 25. That is a rational number because we can write it as 5 over 1. As a matter of fact, the square root of 25 is a natural number because the square root of 25 is 5. There are other numbers, though, that we cannot take the square root of and get a pretty number, a natural number. For example, if we take the square root of 3. That's not 1 times 1, it's not 2 times 2. The square root of 3 is an irrational number. It is a decimal that goes on forever and there is no pattern in that decimal. So a way to think about irrational numbers are decimals that do not have any pattern to it and they go on forever. And these are some common ways that we can classify numbers. And now finally, let's finish up with this example. Jane has 4 pennies, 3 dimes, and $7. How many cents does she have? So she has 4 pennies. 4 pennies is 4 cents. So we can write that as 0.04. Now let's be careful with the next one. 3 dimes. 1 dime is 10 cents. If you have 3 dimes, you have 30 cents. So 0.3, and yes, we typically do add a 0 here, though we don't really need that one. But that is 30 cents, that's 3 dimes, and then lastly we have $7. $7, if I line up these decimals and I add these zeros here just to fill in those spaces, this is 4 pennies, 4 cents, this is 30 cents, 3 dimes, and this is $7. Now if we add this up, Jane has $7.34. However, that is not the answer to this question. It says, how many cents does she have? We could say this. For some weird reason, if she were to go to cash all this in and exchange all of this money for just pennies, how many cents is really saying the same thing as how many pennies would she have if she cashed all of this in for just pennies? How many cents? So if you think about cents and pennies, $1 is actually 100 pennies, right? Well, Jane has $7 here. If $1 is 100 pennies or $1 is 100 cents, that means $7 is going to be 700 cents. Well, if you look at your answer choices, we have 734 cents and 743 cents. These two are clearly not the answer because these are not in the 700s. The answer to this question is going to be C because the $7, that's 700 cents, and then we have the additional 34 cents right here. That's exactly what we have right there. So yes, Jane does have $7.34. But if we talk about just cents, that's going to be 734 cents. 734 pennies, that would equal $7.34. And there you have it, a lesson on numbers, place value, some of the basics of place value, how we can classify numbers, and then we have an example to round out this lesson. And that's it for this video. Smart Addition will see you in the next lesson.